Begin today's proceedings, I would like to warmly welcome our dignitaries on the dais for the first session, which is going to be on about quantum space, secure, precise, and powerful. Chair and moderator for this session is Dr. N. Ranjan, outstanding scientist and director, DFTM DRDO. Dr. Anindita Banerjee, Senior Quantum Technologist, CDAC. Richa Hukumchand, Founder and CEO, Pramatra Space. Mr. Kannan K, Co-founder and CEO, AugSense Lab. Dr. Vishal Saraswat, Bosch Cybersecurity University. I would like all the dignitaries to take the dais.
Can you get some hand mics? So, I'll just, good morning everyone, and my panelists, Anindita, Richa, Mr. Kannan, Dr. Vishal. We had a quick chat on WhatsApp yesterday to how to go about this session. And I'm glad that we are part of this. We thank SIA for inviting us and organizing this session, especially when today our Indian cosmonaut has reached ISS along with 3 co-passengers, and it's a great feeling for all of us. I hope this has been discussed and we have realized that they are almost planning 60 experiments and trying to gain some more knowledge on the space. But I'm sure quantum is still far away from that. So quantum itself is quite difficult. But then, quantum technologies, physics is robust. The understanding is quite well with all the physicists, and they are poised to redefine the architecture of secure communication, precision sensing, high performance computing, and the implication of that on the civilian life and defense, national defense, space infrastructure, cryptographic resilience is sure, and the theory has proven that. Now, the theory was proven quite some time back, and last 10 years have seen a lot of investment in the quantum technologies. I personally understand that most of it is government funding, because the quantum requires a lot of infrastructure, a lot of kind of instrument that required to do the research. Right now, the National Quantum Mission of India is going on, and they are giving a lot of research funding to most of the institutes which are involved in this area. And there are quantum hubs. If you know that one of the quantum hub is at IIT Delhi, IIT Bombay, IIT Madras, and they are doing considerable amount of work. And I will give you a quick update. 10 days back itself, one of our DIA COE centers, and that is the center which I am driving those centers. The 1 kilometer QKD on entangled photons has been done in the free space optics. Now, this is, I wouldn't say it's a one step towards better solutions. The claims in the international global research is in terms of kilometers, or the satellite-based QKD has been reported by many research papers. And I think we need to really look at it, that how they are optimizing and how they are going to make it more packaged version, which is robust enough to, go through the vagaries of the rocket launch and then be in the space and do the QKD. But the QKD is one of the it's the burning area where, it will be very useful, and that's the first low hanging fruit that everybody wants to target, to use the quantum for QKD, and satellite QKD will solve a lot of logistics problem of the key distribution. And this will pave the way for the communication, free space communication. Also, you have the, the technologies which are required, whether it's heralded photons, the photon sources, or the entangled photons and their sources, all are going to drive the technology, how we use it in the future. Now, this is, I'm talking about the research perspective in the universities that's happening, and we have esteemed panelists who are actually driving it in the package form, and the technology which are being made for the practical usage for deployment. And we had a bit of a understanding that what questions we are going to be answering. I hope they are come prepared for that. Dr. Anindita is a senior quantum technologist at CDAC. She's already a PhD from JP, and I thought she's also working on quantum circuit optimization and communication protocols, right? Richa Hukumchand is CEO of Pramatra Space. Very happy to see you leading a startup, that too in one of the most difficult, I would say physics, engineering, optics, everything, communication together. See, why these fields are very difficult is there is a lot of interdisciplinary understanding of the science as well as technology and engineering required. Then we have Mr. Kannan, again young co-founder of the AugSense lab. I think he is working on to the quantum-enabled radar systems and conventional radar design through research in quantum sensing, right? The ghost sensing, that's what I think the term coined for such technologies. And we listen from him where we are on that. And then Vishal Saraswat, Dr. Vishal Saraswat, who is the program manager of the Bosch Cybersecurity University. Again, his field is PQC. And I think when I talked about the quantum QKD and quantum communication, PQC is the even lowest hanging fruit that we must all transition to. And that's where he comes in, and he will throw some light on the PQC. How do we go about it? And I think he has got a lot of publications also. And he is also executive committee member of the cryptology. So we have very good panel, and they all know, and we also are trying to keep a tab what's happening in the country in terms of quantum technology. And quantum technology related to space. The idea is whatever is happening, we can't have too much of time to transition to the space. It has to go in the parallel. The thought processes have to work together, and we have to make sure that as we are practicing on the tabletop, today the whole problem lies in only one thing: from the tabletop, the experiments which are successful, how do we go to the product stage, how do we deploy it into the useful scenarios? And that's where all these startups play a very vital role for the entire ecosystems. And I will request all of them to throw this, whatever questions we have raised. I will be bringing out some of the questions once again, and we will ask each of them, and then we can take the question answer session. Probably at the end of it, I will request let them speak, and then we can have a question answer session, which should be very focused on how do we make it possible, or how do we accelerate ourselves in the quantum zone, and how do we take it to the space. Anindita. The question to Anindita is basically, what strategic areas should India prioritize to build a robust quantum technology ecosystem? And I think given her experience, vast experience, technical as well as managerial, I think she will be able to throw some very important aspects of the ecosystem.
Thank you, ma'am. Thank you, ma'am. So, we know that under National Quantum Mission, there are 4 verticals: communication, quantum computing, quantum sensing and metrology, and quantum materials. All these 4 verticals are interdependent on each other, and they don't exist in isolation. And out of all these 4 verticals, what is a very important vertical to consider would definitely be quantum communication. Why? Because quantum communication's role is primarily providing security. We know because of the principles of quantum mechanics, superposition, entanglement, there are quantum algorithms which, if given a fault-tolerant quantum computer, would be able to break some mathematical problem statements in polynomial time. What does that mean? The problem today, all our passwords, all our secrecy is dependent on mathematical problem statements. It's complexity. Now, the complexity class to which these problem statements belong, for example, the prime factorization, Diffie-Hellman, discrete logs, all these complexity class comes under DQP in quantum computing, which can be broken. So now the importance is again the realization of a quantum computer, which is already happening. We recently have heard that, of course, Google Willow, chip Willow, and then you have I think yesterday I was reading of a Chinese company coming out with 1,000-qubit quantum chip. We do not know how true it is, but there is also, we cannot keep on neglecting these facts. And since I'm coming from an academic background, we do study research papers. And when I was working in CUNY, I left it 3 years back. That time, I moved from studying research papers to study the white papers, the product roadmaps of different startups around the world to understand how Indian startup can give a competitive edge. So that is where I realized, many things are happening. They may not be as true as they sound, but things are happening, and you can see the results being published in these research papers. So there is a lot, I would say, a large amount of truth in it, and when there is a mandate by Europe and US to transition to PQC by 2035, which is about 10 years from now. So some thinking has gone to it. Why 10 years? We know that any cryptographic system is secure as long as the transition and the shelf life is less than the realization of a quantum computer, which is, by the way, in TRL 7. TRL 7 means where you are the system or the prototype is being tested in some relevant environment. And that is the reason we are buying. There was a news by Quantum Valley where we are buying a 150-qubit IBM quantum computer. So we are buying. So the machine is already there. And what has Google done? It is actually, they have improvised error correction algorithm, materials. They are also working with new materials for quantum computing. So all this is going to lead to a space where 2035 is important. According to the most pessimistic view, there is about 70% chance by 2035 to 2040 to get a crypto cracking quantum machine. These are facts. So that is the reason, again, you will see almost all the standardization agencies around the world, you name and you will find that they are working in the quantum space. You look into the satellite. So China has 3 satellites and 4 ground stations. Then we have European Eutelsat, which is working with a defense company, with the government, and they're coming out with, a quantum internet. So they're covering the much more applications that we can imagine. In India, we have DRDO working in that space, we have PRL, we have ISRO, we have SAT, because we have done an MOU with SAT. So they have already prepared a payload, quantum satellite payload. Okay? At CDAC, we are so what happened after coming out from QNU Labs, I was looking into the space, what to do next. There is intense competition, so there is a terrestrial QKD also, which is happening in India, and there was satellite. Nobody was talking about the middle layer, which was the aerial communications. That is where I put my project into. So we are building an aerial quantum communication device with industry partner, Sagar Defense Engineering, where we bring the quantum and they bring the drone part, and we will be doing some technology demonstrations. And we are not the first one. China is there, US is there. Most likely we are the third. But this is how we are progressing. I think we do not have time. There is a lot to catch up. There are standards coming out, which means that it is not in an R&D phase. Okay, there are products out, so it's a very important sector, the strategic sector. And yeah, I think I can keep on saying many things, but I would stop here. We all understand that is the most important part.
Thanks, Anindita. We'll come back to you. I'll go back to come to Richa. So what motivated you to establish Pramatra space in such a specialized domain as quantum cryptography? And especially you don't have the external funding. You have funding it yourself, I believe. So you can also work around, the cryptography validation aspect if you have, because there is a very rigorous process required to actually prove the crypto and the security of the crypto that you are offering. So have you thought about how do you go about the validation of this?
Thank you so much, Ranjana ma'am. And I think first I would like to really thank SIA that yes, they gave me the platform to speak and voice all the challenges that we face. I'm founder and CEO of Pramatra Space, and we are a quantum security company working at the intersection of photonics, space, and quantum. Right? That means we have picked up a very specific problem and looking at to solve it. Coming to your questions, I'll break it into two. The first is where do you get the motivation from and how you're surviving. So I think Ranjana ma'am, you will relate to this because my motivation is, I would say, deep rooted in DRDO. I was privileged enough to work with, when I started my career in 2003, and I was privileged enough to work with some of the eminent scientists and the lab set up by none other than Dr. APJ Kalam. I worked with Dr. VK Saraswat. So that motivation was deep rooted, and there's a huge desire to solve challenging problems. And later on also in my career, I have worked with companies like Pixel Space, which is one of India's successful startups, which has helped in taking the whole economy up, right? So when I started looking at, after Pixel, when I started looking at the security space of space and a space infrastructure, it was very clear to me that the traditional secure systems, which are more digital or mathematical based encryption systems, will not be sufficient enough, and what you require is more physics based cryptographic solution. And soon during that year 2022 is where the three eminent scientists at a global level got the Nobel Prize for proving the quantum entanglement. So that also gave me a conviction that this is the technology for the future, which needs to be built in, right, from now itself, right, before it's late. And I started working on that, solving on that. When I looked and researched at a global level, there have been a lot of efforts, especially Europe and China are way ahead of us. Even 2 years back, they were way ahead. And what I was observing is that it's not just the government funding or the government entities which are contributing into this space. The academia, government, and even the startup ecosystem or corporate is putting a huge effort. You name it in terms of the pilots that have been done by Toshiba, HSBC, even AWS. So that is where I even got the conviction that from a national perspective to solve not just the national security problem, but the whole problem that will be faced by the financial infrastructure, there is a huge opportunity that I saw that yes, commercial efforts and commercial angle can be looked at. That is what motivated me. Now, coming to the question of where I am getting the support, so I would like to clarify, I am not necessarily funding it all together. Yes, initially when we started up, we did a very small bootstrapping, but I've been privileged enough to get the support. And when you see the support, what kind of a support we have got, right? MITI supported us initially. We got an industry support from NXP Semiconductors in terms of helping the market validation and how they are looking at for the whole automotive segment. This was done in collaboration with the Government of India efforts. We have been supported by InSpace, and I must say that the Government of India program of InSpace, what has set up in terms of even the tools, so that saves a lot of cost. So what you have to end up investing, so if you look at challenges or what is the biggest challenge if you'll talk about for a startup success, there are three major pillars. You need capital talent, you need infrastructure, as you also spoke about, and the third angle is the market traction or industry validation. I would say yes, government solves a lot of challenge and support on the tools and infrastructure. Right now we've even started talking and discussing with IIT Madras on how, so they have, I think in terms of photonics based solutions of quantum, if you look, IIT Madras is the only institute which has set up facility which can do the validation and testing at a wafer level or a chip level. You need not do the packaging for that. So we have got a lot of support that provides us, plus in my networking and the contribution that I have done throughout my career at different companies, I have been privileged enough to prove and where they have the confidence in getting all the angel investment in place. So that's the our secret sauce of being surviving and escaping the valley of death.
So thank you, Richa. That was quite inspiring. I think a lot of people can take the plunge. Mr. Kannan, you are co-founder and executive director, and you have taken quite a big challenge. Radar itself is a very complex system, and you have gone one step ahead, talking about the quantum enhanced radar system. So what are the biggest engineering or integration challenges you face or you foresee for transitioning from the conventional to quantum radar architectures? A little bit for the audience, primarily the challenges, I don't know technically how well we'll be able to appreciate, but yes, I personally would like to listen to the technical challenges first and then the other challenges.
Thank you, ma'am. Thank you, SIA. Distinguished fellows in the industry on the panel of the panel. sensing on the context of RF initiative. We have a plan to get into positioning system, magnetometry, etc. If you see the RF modalities in satellite industry, we are not very specific to only to satellite, even drone, ground-based sensing, missiles on telescope. RF modalities like synthetic aperture radar, electronic warfare systems, even radio meter, this has started its journey from 1960s, 1978, etc. So I feel like we had a history of 50 years than conventional technologies. But when it comes to the demand for these modalities, the band it needs to support, the kind of resolution it needed, the way it needs to be designed has increased a lot. And certain modalities in the current form is not suitable for a commercial launch. For example, radio meter. It's a wonderful tool for weather sensing, heat island sensing, etc. But currently only a ISRO kind of organization can invest in this because that kind of a design challenge for a conventional radio meter to be implemented, you need a lot of antenna arrays, a lot of design challenges out there. So how we approach, why we are utilizing quantum sensing is, one, increase the sensitivity of the current radars. Second, all the current radars, if you see that antenna design is very complicated. You need a specific antenna for a specific band. Like you need an L-band antenna for L-band, B-band, S-band and X-band. And if you wanted to build a electronic warfare system 0.1 to 40 gigahertz, you need to stitch so many antennas. It's not only just stitching so many antennas, it is also to create the supporting electronics, matching up converter, down converter, etc. One, to answer your one question is, when we implement quantum sensing, some of the engineering challenges faced by the conventional radar design will go away, because you can have a universal wideband antenna, and we are going towards a radar design without antenna. So that's going to be one advantage. Second, the noise floor will be reduced, so the sensitivity will be increased, and the swath of the current radar designs will increase. But the challenge for implementing is one, the quantum sensors today or tomorrow will come up with an enormous different type of data, and it has to convert or work with the existing conventional digital system. That integration will be there. But the major challenge as a country which we are going to face in implementing this is, quantum itself is a multidisciplinary system, and it needs laser design, it needs big fabbing, it needs tunable laser creation, etc. And as a country, we have not really invested a lot in photonics as a discipline, and we are we are looking towards a scary truth that photonics might replace electronics or coexist with electronics, and we need to ramp up our photonics design capabilities across. That's going to be one of the challenges which we are also going to, how to ramp up on photonics design. We have some, including DRDO, IIT Roorkee, some pocket facilities are there. We are also working with international fab facilities and etc. How better we could be able to go work with them, that will decide how fast we can.
I just wanted to add that photonics, a lot of initiatives have been taken. There's a optics lab, very advanced optics lab at IIT Delhi, and photonics packaging facility at IISc. So you are welcome to approach them and get it used, because primarily Vishal, Saraswat. I would like to, you are passionate about PQC.
Yep.
And she talked about PQC going in 2035. But probably we have, but when we were making the India's quantum roadmap, the talk was about 2030 and some work was started. Can you throw some light on technicalities around it and how we will be able to make it a reality that before the quantum computer comes, we are PQC secure at least?
Yes. So this is working, right? Wait. Yeah. So when we talk about quantum computing, and as you mentioned, we believe most of the cryptographers, most of the computer scientists, most of the quantum physicists, they believe that somewhere around 2035 there will be a quantum computer large enough to crack current cryptography. So why worry now? We'll worry when it's there. Maybe it won't be there even 10 years later. The thing is, there are a lot of security is required, a lot of privacy is required, a lot of cybersecurity in general is required, which needs to be true not just today, but even 10 years down the line, 20 years down the line. We have secrets from 20 years ago which we haven't told anybody. Right? We possibly will have secrets which we don't want to be known to anybody even after our death. Right? So when you are talking about national security, and when you are talking about, we are in satellite industry conference, when we are talking about such expensive machinery which goes out in the space and is there for a pretty long lifetime, how do you ensure the cybersecurity of that machine that's out there, which you won't be able to easily access, which you won't be able to easily upgrade the firmware of 10 years from now, or 20 years from now, or even 30 years from now? So that's where PQC comes into the picture, that you ensure you implement cryptography in a way on your current computers, on your phones, on your smartwatches, on your pacemakers, on your satellites, on your critical infrastructure now, so that 10 years down the line, 15 years down the line, your product is still secure, your communication is still secure, your secrets are still secure. So from our country's perspective, where are we? Of course, a lot of the intelligence agencies, I know that they have been at least working since 2009 on the topic. That was my first contact with the various defense agencies, whether it be, you take any acronym. So that has been happening. And a lot of smart people in those agencies, they are working on the topic. They have funded a lot of academic research. And everywhere in the world, when it comes to cryptography, the initial investors are generally the defense guys. Though somehow for post-quantum crypto, my first projects came actually from the healthcare industry, somewhere in 2006. So that's a different line anyway. So at our country right now, almost every institute of national importance, like whether it be IIT or IIIT or NIT, I think almost all of them now are working on PQC. But we are still many, like at least, if not, we are at least 3 degrees, like if we have hundreds of people working on now, experts, there might be like thousands of people who are claiming to be working on it, but experts. We know many more. Because when it comes to PQC, right now most of the academic institutes who are working, and even a lot of the intelligence agencies and the defense agencies they are working, they are just catching up with the NIST standards. They are following the NIST standards, they are just doing it. But we have already seen with NIST that a lot of algorithms that they were in the PQC competition, they had almost finalized, they were broken overnight. So you can't just trust NIST. Anyway, we have seen in past that NIST very likely deliberately published insecure algorithms. Okay. We have seen very reputed companies like RSA, they took bribes to publish insecure implementation. So most of our industry standards are secured by RSA or some sort of ECC, electrical cryptography, or NIST standards. We know for a fact by proven in the court of law kind of facts that they were deliberately insecure. So relying on those will be a mistake. So even though we are catching up with NIST, first thing that our country needs to do is do their own validation. This is really secure. Okay. And also develop their own indigenous algorithm. Not just a tiny modification of the NIST, but really indigenous. Try alternate ones. So that is something that the government needs to do. There is a lot of fragmentation among academia, among agencies. So let's say the defense agencies, they are working in a way, the intelligence agencies, they are working in one way, and then ISRO has its own program going on. No coordination. You are investing thousands of crores, maybe more. Coordinate, possibly you will have a better outcome. So that is something that we need to know. We have also, though we entered into hardware much late, so our hardware is possibly advanced than other satellites which are already in the space, for example. But still now they are what we call legacy. Those will need to be updated if you want them to be functioning. Test it out on your own, how much you really can upgrade without hardware upgrades, just with let's say some firmware, etc., software, etc. So that testing has to be done. So that's what I do. Earlier I was doing it for agencies in the United States, and then I was doing for agencies in our country, and now I'm doing it in industry. That validating the algorithms, ensuring, or even putting an extra layer of defense on those algorithms. So because for many standard compliance, if I need to sell my product, if I need to put my product in a satellite, it has to comply with certain standards. So I have to have those NIST standards, let's say. Then put an extra layer of defense that if that fails, my thing comes into picture.
These are very pertinent points. So the standard that you follow, and then you have to make sure that standard is not misleading you anyway.
Yeah.
So a lot of ingenuity required and coordination required. So I just, these are important points to be taken note of. I would like to only add just 2-3 points here. So that is why the centers that we are running here, DRDO Industry Academia Centers of Excellence, we have made a vertical kind of approach into hub and spoke, so that like quantum, we have 2 verticals, one quantum communication at IIT Delhi and the quantum sensing at ISC Bangalore. Now anything across the country on quantum sensing will go through that vertical, and there is an expert committee following that. So I think same concept even National Quantum Mission is following, that the experts in one particular area are distributing the projects which are basically in that domain. So they have a integrated view of what is happening in that particular field. Now, there is some lack of integration, and that's why National Quantum Mission is brought. So we are part of the National Quantum Mission, and we report all these stuff to them. What more can be done? Because this is what is our attempts, or the steps that we have taken to solve a lot of issues. So I will ask Anindita that what more can be done, so that there can be some takeaway just of the thought that what better public-private academic partnerships can be worked out so that we have an edge. We also got a hint that yes, there are certain papers which are not giving us the right directions, and these are well-cited papers. How do we go around these aspects?
Thank you, ma'am. I would also like to add to what sir was saying, and for the audience. So there are a lot of products in the market for PQC as well. DOT, CDOT has taken out a rugged PQC. Then we have Synergy Quantum. Then we have 42 labs in Pune. They are working on PQC integrated applications. Then there is Mighty is also working on developing a PQC hardware. DOT, of course, they have come out with standards, draft standards for PQC. So lot of actions is happening. Now, one more interesting, I would like to take your attention here, ma'am. Whenever there is an application, today everything is on supercomputing facility. So supercomputing applications, critical applications has to be PQC secure. So we were doing this exercise on Param Rudra, and so they have these graphic cards which supports PQC. And during that experimentation, we realized that any supercomputing application, be it healthcare, be it strategic, be it defense, be it finance, there is a challenge there, and an HPC has to play an important role in there, right? And also because there is a lot of latency, the key size, the security parameter, and the key size, there's a trade-off. So, how are we approaching this problem? If we are a little late, then that gives us an advantage to see the picture, how it is evolving. So coming out with PQC on the accelerator card such that it is also HPC enabled, so that will be very interesting. And whenever we go for any secure communication, because PQC is assumed to be quantum safe, and QKD has lot of things to do because it's a hardware base, there will be a lot of loopholes. Obviously, it's classical is 70 years old and quantum is just happening. So a lot of security patches has to be there, but integrated PQC QKD is the way out. And I always believe that there is a lot of strength in unity. So we just imagine, with the start of this National Quantum Mission and AICTE on quantum education, and you have opened this quantum to all the disciplines now, and you have young minds working on it, thinking of new applications. So we kind of encourage them to take up startups to build, because there is a lot of requirement of manpower there to build and an exposure on the quantum infrastructure. Quantum infrastructure and classical infrastructure are very different, and the cost is very high, maintenance is required. So, so from there, we have this system of government, academia, young startups, industries, experienced industries. One thing using this platform I would also like to emphasize is, since this quantum transition is happening in the national ecosystem, what is happening is the people are taking crash courses and trying to, say that we, for me, it's very difficult to understand because still I'm not very sure what quantum, it is still, the more you see the application, you get fascinated by just quantum superposition and entanglement when you see it really happening, and that is my motivation. So that comes when you have a feel on the subject. It's very important for the government, DRDO, to open up infrastructures for the common public, only superposition entanglement. The kind of confidence it will give to the young minds and to the teachers, that will be amazing. And from there, I would like to link up since I'm coming from startup, and there, Mr. Karunakaran had asked me, I joined startup to make publish some papers, experimental papers, and then apply as a faculty. But then I met Karunakaranji, and he said that you make a choice. You have 0 publication and you work on the product, or you have publication and don't work on my product. And that is where I had taken a choice, and I'm very happy about it. And I also tell my team, because I think I am grooming a team which I would want to come out of my lab and be part of any industry who is actually looking into establishing a quantum lab or transitioning into quantum. So there again, the idea is that we have this kind of public and private engagement. Another important thing is whenever we write a project, whenever I do a project, madam, I always include an industry with me. I mean, because I'm kind of, have been so far doing good in bringing things from TRL2 to TRL4. But the moment you go from TRL4 to 5 and 6, there is this R&D and industry. Academia may be in the consultancy mode. And after that, the industry has to be the leader, and we all have to be in the back foot in the consultancy. So that kind of an partnership where we give equal importance to academia, of course, yes, but till TRL2, TRL3, but then you have to have a government R&D organization or any R&D organization to take it from that level to the industry, work with industry, then the industry takes over. So there are EOIs. I have been part of formulating an EOI for quantum. We had 10 startups, but at the same time, there is a lot of delay happening in getting the projects sanctioned. And you see, the startup cannot wait so much. They have to survive. They have to nourish. So that is again now I think National Quantum Mission is DST is doing an amazing role, and they have supported many. But I think still more, India is a big country.
I think the critical mass that is required for this to getting accelerated to the the speed that we desire, I think that is being built, I think, very well. So here, whenever we are giving the projects, those projects are actually related to some deliverable. Either it's a tabletop deliverable or then transferring it to the industry seamlessly, like she has mentioned. That is the model that is active, because that caters for the translational part from the research to the deployable kind of a solution or a product. If it's a product, fine. Otherwise, a deployable solution that we are looking at. Now, I'll come to you, Pramatra. Richa, what are the biggest challenges that you see? So critical mass, basically, we are trying to build everywhere. So if I give a project, if they ask for 3 JRFs and 4 JRFs, we say please double it, because we want more people to actually hands-on with this, because they can be absorbed by the upcoming startups which are going to work on it. So we have been very liberal with the funding of the manpower specifically, and especially in the deep tech areas. So what is your vision, that what are you looking for to actually make that happen? The startup to actually start delivering and becoming self-sustaining.
Yeah, I can have a big list when we speak about challenging for both what we want and even what we want to rank.
That gives a clue to the policymakers.
But then I'll be a little more specific, and let's come to what are our challenges at specific to what stage we are. And if you look at it, it's been 2 years when we started up, and to look back, what are the kind of, yes, we did face a lot of challenges, and that's all the points that we already discussed. One is the challenge on the talent, the other is the challenge on the infrastructure where you can test it up. The third is the industry validation, right? And with those challenges, at least the achievements that we were able to mark or clear those milestones, first was that yes, get our first prototype in place, and we have been, and when I started looking at a specific problem, which was to look at reducing the size of QKD transceiver devices. How do you reduce the size? Second is what kind of a performance you're getting on that, and the third is what is the cost of it. So in terms of size, we have been able to achieve for entanglement-based system, we realized almost 2 prototypes, and for one at least we are very confident that we are converting it into a product by the end of the year. The challenges that we faced while coming to and reaching to this, one is of course the industry validation, and as we already spoke about, that there are so many standards Now someone comes up and tells that no, we are not doing DPS or we are not doing cow, but we are doing entanglement, right? That itself is an education. And it's motivating because yes, when you hear in news articles, DRDO collaborating with IIT Delhi, proving an entanglement for us, that gives us that's an indication. That's a very big indication to the industry that, okay, no, entanglement is the right, where we started it up 2 years back on that, but it's a challenge.
I'll just add to this. This is FSO-based entangled communication.
Yes.
The 100-kilometer on the spool on fiber entangled-based communication
Yes.
was tested couple of years back.
I understand. I completely understand that. But what I'm trying to say is that even for entanglement, for the industry, that's an education. And only as a collaboration of academia and DRDO, ISRO is what they can send in an indication to the industry to set the right standard. And now then the question becomes, so for example, yes, we had done the prototyping, we have prototypes in our hand, and we have even that is completely 1/10 of the cost of what optical device would do versus a photonics. Now the question comes, how do you prove it, right? You need a clean room, you need a standardization facility for it. So now we are working with IIT Madras that to see that whether we have that capability in the
You're
country.
welcome at IIT Delhi.
It's the same IIT Madras, IIT Delhi. Thank you so much for that thing. We'll definitely initiate the discussion and collaboration. Now the other challenges of what I spoke about is industry validation on to your products. I think the startups, what they face a biggest challenge or biggest threat is they have to escape the valley of death. And yes, government is doing a lot of effort for both, giving the initial where the startup can be moved from TRL level 2 through 4 or even get to a stage where they can get their working prototype. But the industry validation is a must. Without that, you cannot get an idea on that. And I see first time like IDEX program is there that has done a lot of effort. In space recently, I heard that they have specifically working on how a startup can get the industry validation and collaboration on that. We are doing, but there's always a more space, and I'll quote example, US has done it pretty well. There are 2 programs called SBIR and STER, and how they have been beautifully able to structure this up, that SBIR gives a non-dilutive grant which helps even for initial support for first 2 years to startups, and so many startups survive because of that. And the second stage, which is STER grant, which is more to enable and ensure that there is an industry and a academia collaboration for that startup to be in place. And US almost on an annual basis puts up 4 billion, right? If you look at India, I think the advantage that we have so much rich on talent, I don't think so we even need that much amount, because right now what's hot in a global space economy is that what Europe or what US is able to do with X amount of investment, India at the same front would need maybe X by 4, right? And we need to leverage on the rich talent that we have by setting up the right policies and structure around this to see that, okay, now it's time for even IDEX and the other programs to look at the next level, where they find the effort that has been going, how many successes are there on that.
So yeah, I think we are in the right direction, and in fact we do give follow-up projects, so we are not holding the projects at the one level. If it has even 50-60% success, we go for the follow-up project. That's what has been our long-term directed research policy. So a quick question, I think we have time till 12, so we are almost reaching the time. A quick comment, what could be the dual use of the technology that you're working on, the quantum radar?
Currently one is, as I mentioned earlier, we're trying to fix the limitations of the existing radar. What does that means is say if a ground penetrating radar is currently is able to sense only 1 meter, 2 meters, with the quantum enhanced ground penetrating radar, we are trying to do it with 10 meters. What does that, for a defense use case, it is for detecting landmines. But when it comes to disaster management, when a disaster happen, how to avoid the secondary disaster, how to identify a living person faster. So the disaster management will be one. Second is the radar related use cases are very limitedly used in the mining explorations, and the mining industry is also globally is undergoing a tremendous change, and Australia is heavily investing in that, and quantum and mining industry is going in Australia and Canada, and that would be the another one. And the utility mapping, how to detect a gas leak in a very short time precisely so that the downtime can be reduced. So these use cases will increase very much as and when we are able to reduce the swap of the devices which we are using, be it a drone mission, be it a satellite mission or a ground-based.
Swap is anyway the most important part of today, whatever technology you talk about, especially if it has to go on board satellite. It has to have its footprint which is manageable. I know you're from cryptography. Any quick comment on quantum sensing? I think we have not touched that topic.
My company that I'm working, I think we are the largest IP portfolio holder on quantum sensing overnight. Sorry? Yeah. So, yeah, quantum sensing, whether it be at the radar stage or at healthcare, it has a lot of applications. It can increase the precision at least by 2 dimensions, right? And also bring down the sizes of your sensors. The quantum sensing, especially when it comes to, let's say, exploration in, he mentioned mining. When you are doing geo-exploration, drilling, etc., can cause a lot of damage to the ecosystem. Now, if you want to do figure out something below the Arctic, you don't want to just go ahead and drill it, right? So quantum sensing can support you there. So, or your pacemaker or your insulin pump, the quantum sensing can really increase the sensitivity of your accurately knowing your vitals at that moment, and then help you do whatever you need to do the next action. So there a lot of potential, and we are already in POC stage. We have some products which are now getting ready to go into the market. So I personally approved 2 of them, so I know. I'm not a quantum guy, but because I'm one of the I do understand quantum, so they usually bring me on those panels. So one went into the pacemaker, the other is for which will go into geo mining.
So I think with this we have overshot by 5 minutes, but it was wonderful talking to all of you, and it's heartening to see so much development going on. And I think next couple of years we will see something really going up the space and being of practical usage to the humanity that we are looking at. We will open up a lot of academia industry partnerships, and that's the major requirement today. The valleys of death she talked about. In fact, I also feel that tabletop to a product stage is also a valley of death, which really needs a lot of push, because the culturally the academia is good at proving the concepts, but how to convert that concept into a product is something which we really all have to work together in an integrated way to overcome. So I think with these thoughts, we'll keep communicating off the record, and I hand over it to the organizers back.
Thank you to our esteemed panelists for sharing such valuable insights and engaging in a thought-provoking discussion. Your contribution have added great depth and direction to today's dialogue. As a token of gratitude and appreciation, we now present mementos to our esteemed panelists. May I now request Dr. N. Ranjan to present mementos to our panelists. Dr. Anindita. Miss Richa. Mr. Kannan. Dr. Vishal. Now I would request Mr. D.S. Govind Rajan to present memento to our chair. I would request everyone to move forward for the group photo.